So normal distribution has a symmetrical shape.
It's not skewed anyway.
Not skewed anyways, yeah, it's nice and symmetrical, it's got a peak in the middle. But there's also something else about normal distribution, which is the spread of the data and how much data is within certain boundaries. So that's what we're going to look at today. Okay, and what it means to have normal distribution. So you'll see in your textbook it says anything that's measured like a natural thing, like your height, your weight. If you take enough data about enough people, everything will come out sort of being roughly a normal distribution. So that it's not biased in any way for whatever reason. So if you take a nice random sample and record naturally occurring phenomenon, then yeah, so large enough, yeah, you'll end up with a normal distribution. Okay, and what we're going to be looking at is using. Did that symbol work? No. Do you remember what that symbol was for?
Yeah.
What was it again? The mean. Yeah. Mu representing the mean, and this symbol representing the standard deviation. Okay? So we're going to be using those values. So can I get you, there's exploration 2 on page 86. It says you've got a set of data there. You've got test scores and how often they occur. It asks you to calculate the mean, the standard deviation for the data to one decimal place. Now what I want you to do is I want you to do that using your calculator. Alright, so you're going to put it in as a list or a table, whichever calculator you're using, and then you're going to do your statistical calculations. So we're going to do our one variable statistics. Okay? You need, yeah, I can show you how to do it on the end spot, not a problem. Right, so let's just, so hopefully you've got these values. So when we've got a normal distribution, I think we've already taught this through. So we've got a shape like this for our normal distribution. What hopefully you've just found from your data is that the mean should lie in the middle. Are we all following through now? You've got your little toys to play with, but you can put them down now and focus on what we're doing. Okay. Now, we've got a mean. The mean was 5. What was our standard deviation?
1.77. Yeah, 1.77525.
Right. So what does that mean in terms of the chart? All right. When we've got a normal distribution, we've got a mean. And, well, remind me, what does standard deviation mean?
Like how far everything is kind of away from that mean.
Okay. Some points will be less than the standard deviation away, yeah? Some will be more. Why is that? Because the standard deviation is the mean distance
Away
from the
mean.
Yeah? Remember that. Standard deviation is the mean distance from the mean. So some will be less, some will be more. So this is the important thing then for all our distributions. So if I put in lines like this, right, it should be perfectly symmetrical. Mine's not. All right. If I put this in, I'm going to say this point here is the mean, but plus one standard deviation, whatever it is. Yeah? Below here would be the mean minus whatever a standard deviation is. All right. If I go, so that should be directly in the middle. If I go another standard deviation above and below, again it should be perfectly symmetrical. Now I've got the mean minus 2 standard deviations, the mean plus 2 standard deviations. So what does that mean in terms of this information? Well, what that means, what's the mean? 5. So what is the mean plus a standard deviation? 6.77. What's the mean minus 1?
3.3. 4.77. How can it be in the fours?
What?
3.3 or 3.23.
3.23, isn't it? You've all got calculators, you can all check. But, I know, yeah. But that's a common mistake, actually. Just be aware. Subtracting decimals, that's a common mistake. What about 2 standard deviations? That would then be... Tibo? 8 point something, great. Shall I write that down?
8.6, no, 8.42. 8.54.
If you want to go to a different page, you see at the tabs at the top, or you can click your home button. You can always go back to them with your tabs at the bottom. Okay? If you're on the T8 for you just have to click quit. Yeah, that's where the TI inspires a bit different. What's the lower? 1.4? 4.6? And then we'll go one more step, which is a 3rd standard deviation. Okay? So what is the plus a 3rd? So the mean plus 3 standard deviations. Pardon? 10.31 and then negative 0.
Can it be negative with that?
Okay, so this is yeah. So this is a limitation, isn't it? With that. Okay. All right. Now, what I want you to do now, I would like you to look up something. So I know in the T8 for plus, it's called normal CDF. Okay. So whichever calculator you're going to use, all right, you're going to look for normal CDF. So if you're on your laptops with TI Inspire, you need to look that up. I want you to have a look for how to use normal CDF. And what that's going to do is that's going to tell us how much data should fall between certain values. And that's what we're going to look at.
Are we going to have to memorize?
It's not. What I'm asking you to do is find how much data is within certain limits. All right? So I'm basically asking you for what is the probability of finding a value within those limits. Yeah? Does that make sense? So what is the probability of getting a 2 on a dice? Well, what I'm actually looking for is how many 2s are on the dice, right? Make sense? So I'm after that, and I'm after it as a percentage. Now, what I would like you to do is you are going to find out what is the probability, therefore how much data, if it was normally distributed, should there be within 1 standard deviation of the mean, so above and below. Does that make sense? So I'm looking for how many bits of data should fall within this region. Now that makes 3.23 to be my lower bound and 6.77 to be my upper bound. So those are the values that I want you to tell me. Okay?
Oh, and then you have to put in the mean
And then you put in the mean of that data set and you put in the standard deviation that we've already worked out, and it will give you a value which will be a percentage. Okay?
Oh, yeah.
Okay? So if you do normal CDF for this information, you should find out that between 1 standard deviation above and below, you will have, did you all find 68% roughly? Okay? How much data should be within 2 standard deviations? So now I'm asking you to extend it and go from 1.46 to 8.54. So we know that there's got to be 68% of your data between 1. But if I'm now looking at 2 standard deviations, and then once you've done that, go for your 3 standard deviations. How much data should be within those values? Not quite.
You can go above. You can go above that.
Yes, you. But how much should we expect for a normal distribution? Have you worked out those values? So I want to do the same thing again that you did to get 68%, but now have my lower bound and my upper bound another standard deviation further away and another. Okay, just to practice what you're doing as well. So guys, what did you find for within 2 standard deviations? 95. 95.4, and then roughly, and then within 3?
99.7.
That's 9.4. Okay, so what you can see is a normal distribution is not just about the shape. It's about how much of your data must fall within certain boundaries. Right? For it to be normally distributed, you would expect 68% of your data to fall within 1 standard deviation. Right? So let's just have a quick look at that chart in the exploration one. It says, state how many data items are more than 1 standard deviation from the mean. Okay? So what have we got with that chart? You know the one I'm talking about, yeah? In the book? So we've got the mean, and we already had these values. So we had 5, 1 standard deviation. Okay, was what again? No, as a value 6.77. Because the mean was 5 and the standard deviation was 1.77. So the question is, how many items are, well, let's do within 1 standard deviation, right? We should have, if it is normally distributed, we should have 68% of our data. So let's just have a check. So what was the lower value again?
3.23.
Okay, so how much of our data, you look at the table in the book, falls within that realm? So how much is between 3.23 and 4? Sorry, 5. 3.23 and 5. 6, yeah? So I reckon I've got a frequency of 6 there. And then between up to 6.77. There's 15, isn't there? You see why there's 15? Well, look at the table,
Oh, yeah.
right? So the 6 was in the 4, wasn't it? Because that's greater than 3.23. And then the 5 and the 6 is greater than, we had to do that. We couldn't go as far as the 7. Got that? Some people are looking at me blank because you're not looking at the book. Right? You've got to look at the thing I'm looking at. All right? Otherwise, it's not going to make sense to you. Right? How do we check then? So that should be 68% of our data if we've got a normal distribution. All right? So in total, we have 21. How much data is there in total? How much? 32. 21 out of 30. How do I know it's 32? How do I know it's 32? If you've read the book, you can see it. The first time it says. You can believe how many people don't read that? How do I convert 21 out of 32? What do I get as a percentage? 65. Okay. What do you reckon?
Are within one standard deviation.
So we have 65.6% of our data within one standard deviation.
Is that going both ways?
Both ways, within one, above and below. Okay? So I'm looking at that. It's not exact, but are we happy that we're kind of in that normal distribution range? I have 65% of my data within that, within one standard deviation. And what does that matter? Why does that matter?
You could say
Find the
like
data distribution.
the mean kind of.
And say how reliable the mean is.
Yeah, so again, if you're thinking about what you're going to be doing with your projects and things in future, we're now looking at, well, we've talked about taking this middle range, haven't we, and using that to represent everyone in a population. And we're talking about, well, we've got this within one standard deviation. We can say, well, based on the distribution we have, whatever data we've collected, well, it's in normal range, isn't it? Right? If you were going to be looking at, let's say, people's heights, you're going to look at, are people normal? You know, do we have a normal spread of data? Well, you would be expecting that much. Now, what would you infer if I worked out my standard deviation, all right, and I only had something like 34% within one standard deviation? What would you then infer about that? What kind of comments could you make? If there was only 34% of your data within one standard deviation. Comment.
It would, and the mean would still.
So let's say the mean is still 5, the standard deviation is 1.77, because we've worked it out.
Oh, well.
But what would that mean if only 34% of our data? So if I then took this values, because remember that 5 and the 1.77 don't look at the distribution, they just look at all the data, clump it together, work it out. Right? Do you remember we said we can look at the mean and it can be exactly the same for different bits of information? Okay?
It wouldn't be normal distribution, would it?
So what could you infer though from that?
It would kind of be like slanted inwards like that. Like that's what the graph would look like.
I wouldn't necessarily say slanted in, but it would be. Yeah, so you would have less of a peak, wouldn't you? It'd be more spread out. Now that might lead us to think, well, do I have bimodal? Yeah, because if only 34% is in the middle, that means there's more in other places, right?
Yeah.
So that would lead me to consider that. But if I do this calculation and go, right, I'm happy that this is normally distributed, all right? Now why that's important? Because if I'm doing an analysis in a factory of how many things are going wrong in my factory, how many cupcakes are being baked incorrectly, well, I'm going to expect some good, really good, some really bad, but I want the majority. How much do I want sort of around the mean? I want 68%, and if I'm like that, I know I'm within normal parameters. So I would do a statistical analysis like that and say, yeah, everything is within normal parameters.
Why do you want exactly 68%?
Because that's a normal. That's what normal.
68 or more.
That's what normal distribution says. I'm in normal range. Okay. Right. We've got a tough mathematical thing tomorrow. Tomorrow, the next pages, based on this standard deviation stuff. So bring your thinking hats on. It took me about an hour and a half to get through it today.